Assalamualaikum and a very good evening to all my fellow classmates and doctor. So today I will be presenting about sequence and series in cryptology. So we are from group 5. My name is Syarifah Sumaira binti HISHAM, metric number 209299.
Hi, my name is ZULAIKHA binti HADI KAMIL and my matric numbers is 207594.
Hello, my name is KANNAN, son of BALAN. My metric number is 209319.
My name is Muhammad NIZAMUDDin bin BOHARUDIN. My metric number 209317.
Hello, my name is AHMAD RIDZWAN bin GHAZALI. My metric number is 208488. So let's start. So this is our table of content. So for introduction, this assignment were given by our Dr. Muhammad Adil, which is student centered learning, which is basically we need to solve the problem ourselves and present how we solve it to our lecturer. So next, for task 1, I will pass to Nizam.
For the task 1, find the sum of the arithmetic series in 1 denoted by Sn. So for the general formula is An equal A1 plus in bracket n minus 1 and so the astronaut is A1 is a meaning by any term that you want to find, and 1 is the first term, and n the number of term, and d the common difference. Okay, next we go to step to get Sn. So A1 we use the same general formula. Sn equal A1 plus in bracket A1 plus d plus A1 plus 2d plus etc. So in bracket A1 plus in bracket 1 n minus 1 in bracket d in bracket. So this is the first equation. The second equation is Sn equal by in bracket A1 plus in bracket n minus 1 in bracket d in bracket plus in bracket A1 plus in bracket n minus 2 in bracket d in bracket plus etc A1. So this is two equation for the first step. So the next step is add first equation and second equation to get the arithmetic series. So the solution is 2Sn equal by in bracket 2A1 plus in bracket n minus 1 in bracket d in bracket plus in bracket 2A1 plus in bracket n minus 1 in bracket d in bracket plus etc. So the next 2Sn equal by n in bracket 2A1 plus in bracket n minus 1 in bracket d in bracket. So the answer is of the first n term of arithmetic series is Sn equal n over 2 in bracket 2A1 plus in bracket n minus 1 in bracket d in bracket. So this is the step to get Sn. So we go to the next step in task 2.
So based on the first term of the arithmetic series that presented by NIZAMUDDIN in the first task, we get the encryption equation as n equals to n over 2 in bracket 2A1 plus in bracket n minus 1 d times d close bracket. So the alphabet represent the plain text, the numbers continue with the plain text value, ciphertext values, and ciphertext ASC11 table. Next slide. Okay, by using the formula we get from the task 1, we just substitute the value which is in the questions. So the value of d is 14, the value of n is 3. So we use the n value. Use the notes in the encryption equation. Sn equals to n over 2 in bracket 2A1 plus n minus 1 in bracket times d, and we substitute 3 in there with the n, and we will get the solution 3 over 2 in bracket 2A1 plus 28, and the n will be Sn equals to 3A1 plus 42. That's the equation. That's the use this equation to find the ciphertext value. So we will use that equation. So for the ciphertext value for plain text C, we will just replace the A value with 3. If we replace and complete the equation, the answer will be 51. And the ciphertext value for plain text Y, we'll just substitute the value, which is 25. It is in the table actually. So after we substitute and we complete the equation, it will be 117. When A equals to 25, the subtext value equals to 117. That's all. I pass it to the next presenter.
Okay, thank you, Kannan. So as you can see, this is the ASCII table that we get from the website. Inside the slide, we paste the link here. Based on this table, we can identify the ciphertext by using the ciphertext value that Kannan has already explained before. For the previous example, we search for the ciphertext value for plain text C. The ciphertext value is 51. Based on this table, we search for the number 51, and there you get the ciphertext for the plain text C, which is 3. We just continue until we complete the table that the task 2 has given. Okay, next slide. So this is the complete table that we have done. First, we need to know the ciphertext value to identify the ciphertext using the ASCII table. Okay, next slide. The question asks us to encrypt the text below by using the complete table that we have done. The text is "I love mathematics." I'll show you ways to encrypt the text by using the table. Previous slide, Ridwan. The text is "I love mathematics." First, we just see the plain text I and the ciphertext, which is E, and the plain text L, which is N, and O, which is W. So you just have to see the table here to complete the text. Okay, next slide. The answer that we get is ENWL9Q-FB9Q-FE3C. That's all for task 2. For task 3, I'll pass to Hannah.
For this task, we need to build a descriptor function based on task 2. So basically, description is the process of transforming back the unreadable ciphertext to its original plain text so that it can be read. So basically, we just need to reverse the formula from the task 2. So next slide. Okay, we can see we take it the formula from the task 2, which is Sn equal to 3a plus 42. So for this task A, we need to reverse the formula. We make it a as the value we need to find. So it will be a equal to Sn divided by 3 subtract 14. That's it for 3a. For 3b, next slide, describe the text below. So we get the ciphertext that we can read. So we need to translate the ciphertext using the formula before, or we just need to translate by using table we complete in the task 2. So after we get the plain text, get the readable code, which is good job, you did it. From you translate the ciphertext to the plain text. So I think that's all from us. Thank you.